готовы будем начать. Так. Угу.
Dear students, we are glad to see you on our meeting. Our meeting is devoted to it is a part of the open day of our faculty of Mathematics and Mechanics of Moscow State University. And this meeting is devoted to the description of a new academic program, which is called Geometry and Quantum Fields. This is quite new program. It started this academic year. And the program is aimed to the preparation of specialists in famous and very important field of modern mathematics and mathematical physics, which is connected from one hand with geometry and spectral theory of operators, some most modern parts of mathematics, and from the other hand to theoretical and mathematical physics, and especially to chapters of the science which are close to those mathematical disciplines. And now my colleagues will describe more in details the situation about the schedule of the program and the structure of courses and the rules of how you can enter this program. Thank you.
So suppose it's my turn. So thank you, Andrei Igorovich. My name is Maxim Grigoriev. I am a deputy director of Institute of Theoretical for Theoretical and Mathematical Physics of Moscow State University. And as you probably saw, this program is organized jointly by two departments, by a Faculty of Mechanics and Mathematics and our institute. So let me share my screen. Yeah, I'm allowed, and show you a few slides about the content of the program. So the title of the name of the program is Geometry and Quantum Fields. So as I already said, it is a joint program of the faculty and the institute. And it's a course in mathematics and theoretical physics, and the program focuses on physics and mathematics of fundamental interactions, with a certain emphasis on quantum gravity as one of the most challenging problems in this area. And a rather unique feature of this program is a combination of mathematical courses, first of all courses in geometry, with a systematic education in quantum field theory, gravity, string theory, and holography, and other related areas. The program also includes an individual research project, which should be supervised by leading researchers from Moscow State University or researchers from other institutes in other research institute in Moscow. Our directors are Professor Andrei Shafarevich, who just gave an introduction, the Dean of the Faculty of Mechanics and Mathematics, and Professor Arkady Zeitlin, who is the director of the Institute for Theoretical and Mathematical Physics. So what is the concept of the program? The concept is to combine a solid background in mathematics with a systematic education in the theory of fundamental interactions. Why it is important? Why we believe this is a good idea? The point is that despite the incredible and rather fascinating developments over the last decades, the crucial problems in the theory of fundamental interactions, in our understanding of fundamental forces of nature, are still open. These are problems like problem of quantum gravity, like problem of dark matter, and many others. And it turned out from the very early days of the development of these areas of physics and mathematics that there are close ties between fundamental interactions and geometry. Well, mathematics in general, but geometry first of all. And the standard, like kind of canonical example of this relation is the relation between Einstein gravity and Riemannian and Cartan geometry. Historically, these things were even being developed more or less at the same time, and there was a strong interaction between physicists and mathematicians working in these areas. This relation became even richer in 60s or 70s of previous century with the development of the gauge theories, which are the theories which describe other fundamental interactions such as strong interaction, weak interaction, and closely related to it electromagnetic interaction. And from geometrical point of view, from mathematical point of view, this corresponds to the theory of fiber bundles and connections therein. Actually, gauge fields geometrically are kind of connections. And it's also closely related to the study of characteristic classes, certain elements of homological algebras, and other areas of modern mathematics. And even more, even richer, this relation became with the development of string theory, which is considered to be a possible candidate also for a theory of fundamental interactions, including gravity, and at least it's the only reasonable candidate for quantum gravity from physics point of view. And here the mathematics is extremely rich. This involves theory of Riemann surfaces, infinite dimensional algebra, scalar geometry, conformal geometry, non-commutative geometry, supermathematics, mirror symmetry, etc. This can be a very long list. But the interaction also goes other way around. And so not only tools in mathematics turned out to be useful in application in fundamental physics, but also the ideas and methods originating from quantum field theory and theory of fundamental interactions have led to new developments in math. So these ideas and methods turned out to be original because they came from absolutely different source. So what I said, I hope it justifies the importance of being familiar with both sides of the story, with physics and with mathematics, and this is the main idea of our program. Of course, it's quite a challenging task to put mathematics and physics together within one program, because it makes it quite heavy and extensive, but we believe it is worth the effort. In this program, the students will have a unique and broad indication, obtaining a good starting point for an academic career in both mathematics and physics, but also possibly for a career in more applied areas, including an industry where an ability to think independently and originally is a necessary condition. And as we have already mentioned, this is a joint program. This interdisciplinary nature of this program is reflected in the fact that it is organized by two departments, Faculty of Mechanics and Mathematics and Institute for Theoretical and Mathematical Physics. Let me say a few words about the institute. So it's relatively new. Formally was launched in 2018, but started to function even in the 2000, realistically started to function in 2019. And it's a new research center within Lomonosov, Moscow State University. It is actively involved in teaching, mostly at master's level, but not only, and both in mathematics and physics. So our staff, they teach in physics department and in math and in department of mechanics and mathematics. It is quite international. Our institute, most of positions are filled via the open international calls, and ITMP researchers are involved in teaching and serve as advisors for the diploma projects of our students. And we believe that these institutes provide an international, creative, and friendly environment, which should be stimulating for future and present master students following this master program. And as I already mentioned, our director, Arkady Tsaitin, is a very well-known theoretical physicist who has some classical results in this area in the series of fundamental interactions. Now I want to say a few words about the structure of the program. Sorry. So the courses of the program could be divided into 4 groups. So the first group is basic mathematical courses, which provide systematic mathematical education in the areas relevant for the program. These are courses in geometry, Lie algebras and representations, functional analysis, conformal geometry, theory of PDEs, and elements of homological algebra. The second group contains basic physics courses, which are standard university courses, again relevant for the direction of our program. These are courses on quantum field theory, on general relativity, on elements of string theory, and superstring sigma models. And the third group contains interdisciplinary courses, or maybe you could call it mathematical physics courses, because they are devoted to areas which are at the same time considered as both physics and mathematics. And actually these are maybe from the point of view of present developments, are most interesting areas which are at the edge between mathematics and physics. And these courses involve mathematical theory of black holes, quantum integrable models, topological theory, modern approaches to quantization, two-dimensional conformal theories, and supermathematics. And the last group is a group of more advanced courses, typically elective courses. They are devoted to areas of ongoing research areas where still not everything is fixed, not everything is settled. But at the same time, these courses give a good starting point for independent research in the respective areas, and their teachers of these courses could serve as well. All of our teachers could serve as advisors, but this in particular, and first of all, maybe. Okay, and here are some more details about the study plan. So here are exact names of the courses and names of the authors. On this page, we have basic mathematical courses, then basic physics courses, and here is the list of interdisciplinary courses, which I already mentioned. And finally, we have a list of advanced courses with exact names of courses and names of the teachers. I am not going through each course explicitly, because anyway you can find this information, and probably it's even better to look for this information on our web page, where also abstracts of the courses are present. So I think I am done with a brief introduction to the content of this program. So thank you very much for attention, and I stop sharing screen. Thank you.
So Maxim, I'll take over now. Good afternoon, dear colleagues and all attendees. My name is Anna. I am a curator of the program Geometry in Quantum Fields. In my short presentation, I would like to discuss a little bit in detail application dates and application methods to the program, as well as a little bit about funding opportunities offered by the foundation basis for the students of the program. So also, please allow me to share my screen. So there are several dates and methods allocated for the application to the current program. There is an early admission, which is currently ongoing. It runs from mid-November 2022 and all the way to the spring 2023, namely the beginning of March. There is also a summer admission period, which synchronizes with the general admission to all master's degree programs within the Russian university system. And it's end of June 20th to July 20th, 2023. So early admission, which I will discuss in detail in a moment, is mostly aiming at the international applicants. International applicants who prefer to make a decision early on instead of waiting until the end of the academic year. Summer admission is also open for the international applicants, but mainly for the Russian citizens, as well as certain categories of foreign internationals who are eligible to apply to state-funded programs. For example, the citizens of republics of Kazakhstan, Belarus, and so on. I would also like to bring attention that the Faculty of Mechanics and Mathematics organizes a broad competition in disciplines of mathematics and mechanics, which is called the Universiade Lomonosov. The details and the dates of the Universiade will be announced by the end of this year, but the competition usually runs from January to March. It's a two to three stage competition in mathematics and mechanics. Winners and the laureates of the program of the Universiade will have an advantage upon being admitted to the program. The Universiade is also open for international applicants as well as the Russian applicants. And the Universiade will be conducted in an online mode. So the international applicants who are interested in participating will be able to participate without being present on the territory of the Russian Federation. So let me discuss in depth the early application process. As I have mentioned earlier, the early admission to the program has already begun on November 15th, 2022, and will be open until 1st of March, 2023. It is an online application procedure where we ask all interested parties to submit an application package to the email address admission@itmp.msu.ru. The application package is available at the official website of the program. Here's the official website or web page of the program. I invite all the interested parties to go and check out. The web page has not only the admission requirements and admission documents, it also contains the study plan with the detailed plan and outline of each course that we would offer in the program. I continue. Thus, we invite all the interested parties to compile an application package and submit to this email address. Among the required documents, we invite the applicants to submit an abstract of their research work or bachelor degree thesis or master's degree thesis, which will be reviewed during the application by the admission committee. This admission process also includes an online interview. All applicants who have passed the first stage of selection will be invited to attend a live interview with the admission committee. It will be either organized via Zoom or Teams, and will be allocated in spring 2023, somewhere between March and April. You will be contacted by the program curator or the admission committee themselves. And then in April or May 2023, conditional offers will be dispatched to all candidates who have successfully passed the interview stage of the selection. Again, I invite everybody to visit the website of the program, which contains full and detailed information regarding the program. I especially invite people to review the study plan of the program to assess the suitability of the program to your academic background. And now I would like to discuss a little bit in detail the funding opportunities offered by the foundation basis to all students of the program. The Theoretical Physics and Mathematics Advancement Foundation basis offers several means to support the students of the program. So the funding program of the foundation is non-discriminatory, so it's open for all nationalities, all genders. It aims at attracting talented domestic and international students to the program. And the main goal is to supporting the students of the program during their studies and allowing them to focus on research. The funding and support of the foundation will be granted for the entire duration of the program. However, it's very important to notice that this is a merit-based scholarship and funding program. Upon being admitted to the program, an applicant should provide an evidence of good academic performance and broad extracurricular activities within the disciplines of physics and mathematics to be granted a scholarship or a tuition grant. And at the end of each academic year, all recipients will have to prove their academic performance and research progress, and then the scholarship will be advanced for the next year. So the foundation offers two major means of support to the students. There are up to 10 monthly stipends offered to the students, or there is also a tuition grant that covers tuition fees to the program. So to learn more about the foundation, you may visit the website of the foundation. The address is provided at the bottom of the page. And also, regarding the application to the scholarship of the Basis Foundation, you may find broad information at the official website of the program. And I'd like to stress again that this scholarship is available to all students of all levels and all nationalities, and contains monthly stipends and tuition grants. All right, so I think I have also covered everything I'd like to cover. Thank you very much for your attention.
Thank you very much. I guess for the moment we have no questions. We can wait for a couple of minutes and So still we have no questions, and I think we can finish now. In any case, any questions can be written to us, and of course we will answer. Thank you very much.
Thank you.